Hello, this is John from caveofprogramming.com, and this is a tutorial on sets in Java. So a set is a kind of collection that stores only unique elements, and we'll see how that works in a minute. But I'm going to start here by declaring a variable of the set interface type, and I'm going to make my sets here store strings. Although they could store anything. And in fact, in the next tutorial we're going to look at how to use your own custom objects as elements in a set or as keys in a map. But in this tutorial I'm just going to show you basically how to work with sets using strings or integers or whatever, and I'm going to show you kind of basic set operations like intersection and iterating through a set and that sort of thing. So I'll create a set here that stores strings, and I'll call this variable set1, and I'm going to set that equal to a new hash set which stores, of course, strings. Now I can add elements to my set here by saying set1.add, and let's just add some animals. So I'll add dog there for a start, and I'll copy that, and let's have a few more here. So let's try dog, cat, mouse, snake, bear, and I can output that set very easily by just doing a sysout on the set variable itself, because the toString method of sets is rather nice, and if I run that it's going to show me what's in my set. Now if I were to add the same item again, so like if I say adding duplicate items, I'm going to put this code on caveofprogramming.com so you can peruse it at your leisure. Adding duplicate items does nothing basically. So if I do set1.add, let's add mouse again, and if I run this, unlike with a list, sets only contain unique items, so this setting add will basically have no effect, which is quite handy, and sets are really good for situations where you just want to sort out the duplicates from some whole bunch of things. Now hash set, as you may have noticed here, doesn't remember any kind of order, so let's put a comment here: hash set does not retain order. And hash sets can and will spontaneously rearrange themselves according to no particular logic. So if you want your items to be ordered in a set, don't use a hash set, and certainly don't rely on them being in the same order every time in a hash set. If you want to order your items, then you can use a different kind of set. Let's say here linked hash set remembers the order you added items in, and I'm going to change this to a linked hash set, and let's comment this one out. And with a linked hash set is like a hash set, except that it has a doubly linked list running through your items, so it will keep them in the right order. So I've added them dog, cat, mouse, snake, bear, and here we've got dog, cat, mouse, snake, bear, and you can see that adding the mouse again hasn't caused any rearrangement, it just ignored it because mouse is already in there. And finally, if you want your sets sorted in natural order, you can use tree set. So tree set sorts in natural order, and natural order we're going to explore a bit more in a future tutorial, but for strings, natural order is going to be alphabetical order, and for integers it's going to be sort of 1, 2, 3, 4, 5 and so on, and for doubles, of course it's going to sort them numerically. So if I use a tree set here and I run this, we're going to get bear, cat, dog, mouse, snake. This is alphabetical order now. It's tree set sorts in alphabetical order for strings. Okay, so let's have a look at some common kind of operations that you want to do with sets. So probably the most common thing to do is iterate through the set. So let's have a comment here, iteration. And you can iterate through a set most easily using a for each loop. So if I say for, and I declare a variable of the type of thing that's in my set, and I put a colon there, and then just put the variable that points to the set, then that's going to set element to each element in turn in my set. So if I output this, I'm going to get all the elements in my set. And of course, if it's a hash set, it could be in any order. Tree set, of course, we're going to get it alphabetical order, and a linked hash set is going to be the order that I added them in. So pretty straightforward. And often you want to know if a set has a particular item in it. So does set contain a given item? And sets are kind of optimized for that kind of thing. So you can say, unlike with a list, if you want to find a particular item in a list, you're going to have to look through all the items in it. But sets are optimized for finding particular items quickly. So I can say if set1 dot contains, let's say odd voc, which I know it doesn't, then let's have a sysout here. Sysout contains odd voc. Let's try to spell odd voc correctly. Not that it matters at all. Odd voc, I think that's correct. And let's have another one here. Let's say if set contains cat, which it does, contains cat. So if I run that, it's not going to say contains aardvark, but it's going to say contains cat. So contains just checks if the item's in there or not. If you want to check if a set is empty, you can use the isEmpty method. So I could say here if set1 dot is empty, then let's say sysout set is empty, and let's do that again after I've added items. So it's going to say here set1 is empty, or it should do. Where are we? Set is empty, but set is empty at start. Set is empty after adding. That actually won't happen. So if I run that, of course it's empty to start with, but after I've added items, it's no longer empty. Now there's a bunch of other useful methods, and you can check those out for yourself if you just go to Google and type something like Java 7 or whatever set, and look at the set interface and look at the methods that it lists. So we've got stuff like add all and clear to get rid of all the items from a set, contains all to see if it contains all the elements in a particular collection. It has remove, so you can remove elements, which I won't show you in this tutorial because it's going to get a bit confusing, because I want to show you a couple of other slightly more complex methods. isEmpty, to array, to turn your set to an array. And the two methods that I want to demonstrate to you now are remove all and retain all, because they allow you to perform the kind of mathematical operations of intersection and difference or complement. So let's have a look firstly at intersection. Now I'm going to create a new set here called set2. So let's just copy all this stuff, and I'm going to paste it in down here. So here, and Control-Shift-F to format my code there. And I'm going to change this to set2. I'll get rid of that isEmpty thing, and set2 here. And I'm going to set2, I'm going to add a couple of elements that are in set1. Let's have dog and cat, nice and simple. And let's have some elements that aren't in set1. Let's have giraffe, monkey, and ant. So set2 contains dog and cat, which are in set1, and it contains stuff that's not in set1. And if I want to find out which elements are common to both sets, the first step is you probably want to create a copy of one of your sets, because otherwise you're going to end up messing up the two sets you have. So I'll do this. I'll do like set containing strings, and I'll call it intersection equals new. Let's just use a hash set. That's simplest. In fact, maybe I'll use a linked hash set because it might be a little bit clearer. Or will it? No, you know what? I'll stick with hash set. Hash set is the most kind of lightweight type of set you can use. So usually you use hash set unless there's a particular reason to use tree set or linked hash set. That's going to contain strings, and I'm going to pass to the constructor here my set 1. So I'm going to say here set 1, and what that's going to do is it's going to make intersection a copy of set 1. So if I do sys out here on set 1, let's maximize the editor and I run that. My set here, so set 1 is bear, cat, dog, mouse, snake, and I've just made a copy of it called intersection. Oh, sorry, I've output set 1 by mistake, so that demonstrates nothing. So I'm creating a copy of set 1 and I'm outputting that set. So I run that, and so set 1 is bear, cat, dog, mouse, snake, and my copy called intersection is bear, snake, mouse, cat, dog, which is actually the same. So bear, snake, mouse, cat, dog. Okay. And what I want to do is I want to find out which elements are in this that are only in set 2. And to do that, I can say intersection dot retain all, and then pass it my set 2. So intersection at this point is a copy of set 1 because I passed set 1 to the constructor, and then I say intersection retain all set 2, and that's going to keep only the elements in intersection that are not only in intersection to start with, which is set 1, but are also in set 2. So what I've done here is I've computed the intersection of set 1 and set 2. I've found the elements that are only in both of these sets. So let's put the sys out down here and run that, and you can see I've just got cat, dog because those are the elements that are common to set 1 and set 2. And in fact I'm going to move this comment down here because I want to show you something else here. So I'm going to say here set 2 contains some common elements with set 1 and some new elements. So that was intersection, and the other thing you might want to do is find the difference of two sets. So let's put a comment here, difference. Supposing I create a new set here which is a copy of set 1, again set 1, call this difference. Now supposing I want to find the elements which are in set 1 which are not in set 2, what I can do is I can say difference dot remove all set 2. So difference is going to start off being a copy of set 1, and then I'm going to remove all the elements that are in set 2, and I'm going to be left with just the unique elements in set 1 that are not in set 2. And let's do a sys out here and sys out on difference, and if I run that we can see that in set 1 I've got bear, snake and mouse, and those elements are not in set 2. And of course you could do it the other way around. You could say find the elements that are in set 2 that are not in set 1, and if I do that it's going to be what? Giraffe, monkey and ant. So if I run that and it says giraffe, ant, monkey. So that's it for this tutorial on sets, and as I say, in the next tutorial we're going to look at using your own objects in either sets or as the keys in maps. And to do that, we're going to implement hashcode and equals methods, and we're going to look at some little problems that could arise. So join me again next time. This code will be on caveofprogramming.com, which is all one word. And until next time, happy coding.